Now we shall start with the last session in this room, our Congress. Thank you for coming, and I would like to introduce the first lecturer, Mr. Conor Murray from Ireland. The floor is yours.
Thank you very much. Good morning. Pat, you've given me, I understand, 20 minutes. Is that correct? Good. Okay. So what I'm going to do is, because this is a wider conference, first of all, I'd like to thank the organizers. This is my first time in Belgrade, and I'm delighted to be here. What I'd like to do is to talk to you about the subject of clean rooms, right? And I know this conference is covering a lot of different things on it. So clean rooms is a very narrow area field within that I've been involved in most of my career for the last 40 plus years. So I'd like to tell you a story. I have many slides here, which I'm not going to go through the details on each of the slides, but I would like to try and take you on a journey with me to try and explain the context of clean rooms. Okay, and in this, I'd like to talk first of all about the UN Sustainability Goals, which are 17. But within those, there's a number of those that clean rooms appear within. So we have clean rooms, which is the subject of clean air systems, primarily for manufacturing. But post-COVID, we recognize now with infectious diseases that clean air is now becoming much more important than purely in manufacturing. So it occurs in many, many different areas, from food to microelectronics, to all the devices we use, to pharmaceuticals, to medical devices, and many other applications, including trying to contain the air that occurs in biosafety laboratories. But we have to start off with the global climate challenge. Okay, and I'd simply say that for generations we've been consumers of our natural resources, and we need to reflect on the fact that instead of that we should be custodians. So the thrust of this paper is talking about the road to a circular economy, where we recognize, we talked about embodied carbon, operational carbon, life cycle analysis. But the first thing we're going to do is recognize the importance of education. So in order to change our behavior, we first of all have to be aware of the issues that are involved. So this is, again, a deep dive into the clean room side of it. But what's most striking is how poorly we are doing. So this is a simple chart of our energy consumption over a long period of time. And you can see, obviously, that we are increasing our consumption at a dramatic rate. Unfortunately, we're still consuming huge amounts of fossil fuels. And if anything, our fossil fuels are increasing, like as if we want to drill until we drop. And therefore, we've got to recognize that we have an increasing challenge, that we're building more buildings and we're consuming more, but we're also generating more fossil fuels. So our natural energy and renewable energies are still relatively small. So I would say that we're crawling towards 2050, and maybe we're blindfolded as well. So there's some serious complications on that. However, the future of the circular economy, where we recognize net zero and our contribution, is really around sustainability, including all of the energy sources that go with that, right? Let me start off by giving an example that we have electric vehicles now, larger growing in the last number of years. There's huge clean rooms of the order of 50,000 square meters being built to manufacture, which is currently using lithium ion, but there's new technologies. But we need to change the way we do our clean rooms in that area, and we need to move to a circular economy where we recognize that we need to recycle the batteries. So we've started off with nickel, manganese, cobalt batteries for original cars in the last 10 years, but they're rare earth metals. So we have to find ways of reusing those in a more sensible manner. That's part of the circular economy. So we can't keep building batteries and then landfill them. We've got to find ways to design them that they can be recycled. To give you an idea of the future of where electric vehicles are going in terms of charging, would be you've local charging stations, okay? And again, bear in mind, I'm going to tell you a story, so you're not necessarily going to have to read every slide or every bullet point. But the future is going towards wireless charging on motorways. So we need to be very innovative the way we do things in order to do them in an efficient manner and based also on sustainability in terms of a circular nature of the future economy. Okay, so that was just some examples there, but we live in a changing world with carbon and energy challenges. Unless we change the way we behave, then it's only going to get worse because our growth and our voracity to absorb and use our natural resources is not really slowing down because of increasing demands of other countries around the world. So if we look at clean rooms, right? Clean rooms apply in many different areas. We all use mobile phones. We're using PCs. We have our TVs. So everything is based on communications. And these are electronic devices, which are manufactured in clean rooms with very large energy footprints. Okay. They also run all the time. So 24/7, 365. We can see the rise in the use of data centers, which are huge consumers of energy, but also have embodied carbon parts of them as well. And we're building more and more data centers because our desire for more and more data is only increasing. So our climate change has to recognize we're rushing to consume more energy because we want more data. And we've got to find ways of being smarter in how we actually manage the manufacturing, the preparation, distribution of the data. So the next 50 years are really around recognizing that we're still going to increase our consumption, but we've got to do it in a much more efficient manner, and we've got to recognize the need to find ways of recycling in a more sustainable manner. And again, awareness leads to behavioral change. Okay, so we need to change the way we behave. We also need to educate our youth in terms of how we use our systems and our technology. And I do a lot of work in ASHRAE, and we do a lot of mentorship programs. I also go into schools. So we need to change the way we behave, and we need to start with our children. I am towards the I would call it the sunset of my life. I have 6 grandchildren going from 8 weeks old to 24. So I spend most of my time in my semi-retirement stage of promoting and giving youth the choice. Again, we have to follow this education route, but this specifically is around clean rooms. And I would simply say that clean rooms are at the heart of the problem because we're the biggest consumers, either in hospitals, in life science drug manufacturing, the solar PVs we talked about earlier on, heat pumps. A lot of these sensitive circuits are manufactured within clean rooms. We have higher demands on our drug products and our pharmaceuticals, and we've higher demands in terms of food. Okay. And clean rooms are getting bigger, not smaller. They're getting smaller in terms of cleanliness, but they're also getting bigger in terms of their space requirements. So battery facilities now are 50,000 square meters plus. Okay. And there's 100 projects worldwide being planned around these gigascale factories. So our energy consumption is going to increase unless we change how we behave. The good news, of course, is that the clean rooms are at the heart of the solution for the climate rebalancing and going to a circular economy. But those clean rooms have to be built more on sustainability, agility, and flexibility, and the ability to repurpose clean rooms. So let's talk about a few things within that. One of the big things that's going to make a change in clean rooms in the future is the adoption of BIM, building information modeling, and going towards a digital twin where you actually can digitally see what's going on within a space with the live data. Okay. And that's just one example of that side, right? Ultimately, we have to change how we behave because we've been building clean rooms for decades and over designing them for decades to be safe, either for safe pharmaceuticals or otherwise. But we have to deal with the risk and impact of the lack of cleanliness around either product yield or reliability, or in safety and compliance. I've been involved in writing ISO standards for many, many years, and there are a number of ISO standards that have been written or added to in the last number of years, which have taken a very clear aim on the subject of sustainability. And so I'm going to talk a bit about that. Again, unfortunately, ISO 14644-1 has nearly 20 dashes in it. which in itself is confusing because it covers so many different things. Again, if you're not involved in clean rooms, I won't blind you with science, but just to say there are numerous standards around it. But there are two really, really important standards that are around the design and the change in design around clean rooms. And the first thing, those that are familiar with the concept of air change rates, and typically in buildings, you're looking at very low air change rates for general occupancy, whether it's into schools. Typically, you talk about 4 or 5 air changes per hour. In clean rooms, we've been running up to 600 air changes per hour. And typically, there are 100 plus air changes per hour. So we're looking at an energy footprint that's logarithmic scales higher than normal buildings that we're talking about in the last few days here. So this is a very important sector, but it's a huge consumer of energy. So one of the biggest changes we've made is that we have been working on traditional tables for a number of years that have been completely out of step with the actual requirements for dealing with hazards and the importance of cleanliness for product quality or yield. So we've removed the table of air change rates and we're going back to good engineering practice. However, we've got to change the way we've decades looked up tables, applied design, and huge volumes of air have arisen from that. So we're talking about concepts of air change effectiveness, contamination removal effectiveness to ensure the product quality and yield of the manufactured products or the service that's provided within clean rooms. So we have to work off good science. And within that good science, we've got to look at local air and how air is moved. Hopefully we'll time at the end of this to give you an example of airflow visualization in a facility that I've recently worked on for Novartis in a facility in Slovenia, actually, last year, where in fact we redesigned the HVAC systems and we focused on the efficiency of the system locally to provide containment and removal to give a better product while not conflicting with the compliance requirements on it. Okay, so one of the things we talk about now is getting to equivalent air change rates. But here's an example of a table showing you different aspects of part of an example of a clean room. And all I need you to look at there is that you've the old site standard and the standard based on contamination control strategy or the removal effectiveness. And you're looking at vast increases in energy reduction efficiencies. Okay, so you're looking at dropping the air volumes by 3/4. Traditionally, we over-design, so we need to change how we design with less air, but the air needs to be focused in a better area within that, right? The other standard that's come out in the last number of years is Dash 16 on energy efficiency. So these two dashes, 4 and 16, are the basic bedrock of how we need to redesign clean rooms, both new clean rooms and reviewing the efficiency of existing clean rooms, right? That's just a graphic example within Dash 16, which shows you that you have generation of energy and you have the use of the energy. My focus in clean rooms today will talk about the use of that energy, not the generation side. Okay. One of the interesting things is the fan affinity law, that the air volume and energy is related in a cube manner. So when you reduce your air, you reduce dramatically the electrical energy consumption of the fan motors. So therefore, the secret of reducing energy in clean rooms is to use less air. We spent decades using too much air. So that's a big change in the industry to go to that. Okay. But one of the things I am going to jump to, if I can, is that as summary reduction, the first two things we need to do in clean rooms today is to optimize the air volume flow rates. Not air change rates, air volume flow rates to be effective. And the second thing is when you're not using your clean room to put into setback mode. Because if you're not using the clean room, you're not manufacturing, you're not providing a service, then you don't have any hazard or contamination generation within the space to remove it. I'd like to bring us into the life science industry. There's been a revision of a major document called Annex 1 on good manufacturing practice. And that links to the cost of medicines, the adoption of AI and technology. And there's also a concept called Pharma 5.0, which is very similar to Industry 5.0, which basically brings in AI, automation, and robotics. But it's really around real-time release testing, okay, and predictive quality, all the stuff we've been talking about over the last 2 days. And it's very important that we align the amount of air within a room in a clean room to be as effective as possible. So Annex 1 came out last year and is now giving a number of guidelines to adopt new technology. So you're all familiar with Swiss cheese. I use this as an example to explain that no one measure will achieve the cleanliness and the product performance, but the combination of a number of things. In this case here, you have the facility, you have the engineering controls, you have the control systems, how we behave, you have the quality management system. But on the right-hand side there, you can see a number of what we call critical quality attributes, which includes volatile organic compounds, viable particles, which are microorganisms, total particles, a number of things, as well as standard temperature, humidity, noise, and vibration. So we need to use smart design to get to where we need to. And we need to make sure all the parties and stakeholders come together on the planning side of the clean room facilities, whatever the application is, as well as on the operational side. Again, I'm not going to read all these slides, but there are a number of things about best practice. But basically, best practice is to keep it as small as possible and make sure it does its job. And again, I'm not going to read the slides in it. There's various mechanisms in terms of airflow standards within it, but I'm going to try and give you an example towards the end of this presentation. And I'm watching my time at the moment. And I'm still okay, Bata, for another few minutes? Okay, good. Okay. So these are some elements that you can read later on in the presentation. I'd like to focus on a few mistakes which are common in any project around the world, and I've traveled the world many times in my last 40 years. And the first one is if you do not define what your requirements are as a user, okay, then you cannot expect the designer to design to meet your requirements if you haven't clearly set them out. You also have to set out the expectations of how you measure the performance to achieve your requirements. So all those other things are very common. Those that are project managers, so we're talking to Melina in architecture and different areas of projects, but they're all the standard ones that apply in any industry, not just clean rooms on it, right? A lot of it, in my view, around energy performance is you have to demonstrate the energy performance that you're expecting. You need to show it works in the field. Otherwise, you lose the trust of the owners and the users within that, or even the governments and agencies who provide the funding. If you can't demonstrate that you're designing for energy efficiency, you can't show the results of that. I spend a lot of my time reviewing commissioning, and I find that the commissioning level of detail is poor because the commissioning engineers are given very little time at the end of the project. The designer doesn't review the data, and you don't tune the system within that. However, the future of where we're going to in clean rooms and the HVAC side of things is working on optimization, first of all. So making sure the existing clean rooms work as they're designed. When you're not using them, you switch them back and you have access control to make sure nobody's in the clean rooms. But the future is adaptive control with measurement sensors telling you what the challenge is, where the contamination source strengths are, and modifying the HVAC to do the right type of a job on it, right? So I'm actually going to now finish by showing you a project example. This is a project coming out of Slovenia. The red boxes there show you just one air handling system that we took as an example. There are roughly 40 of these within a number of facilities in Slovenia for Novartis and Sandoz. But it just shows you the complexity that's involved in here. But we drilled into this HVAC system here. There's a number of slides here that show the different rooms. But I want to go to, if I can get this to work, is the ultimate end result was, well, we started off by saying optimizing it, but we work for the Quality and Regulatory Affairs Department, who said we cannot have any challenge to our environmental monitoring data and our product quality because we've a manufacturing license. So we worked very hard on retuning the HVAC systems. And what's shown on the left-hand side here is airflow visualization before and afterwards. And effectively, we reduced the air volume flow rates and we increased the local air change effectiveness by simply tuning the HVAC system. Now, hopefully, the next slide. Now, can I get this video to work? Can you intercede on that side? Good, excellent. So what you're seeing on the left-hand side is the traditional commissioning in one part of this packaging line. And we've glycol generators in that device that looks like a T-piece there. And it's showing you might run the video again if you wouldn't mind. And I wasn't sure how to do a loop control on it. But the left-hand side was the design as it was. The right-hand side shows the retuning of the HVAC system, where we reduce the air volume flow rates by a third, okay? And we improve the efficiency of the contamination removal effectiveness at the same time. So I hope I've taken you in a very quick cook's tour of the clean room industry, of where it has come from, where it needs to go. Hopefully now I'm going to change to the next slide. Thank you. Okay, so ultimately, I'm going to finish in this slide here is that right now, most of the contamination control tends to be microorganisms, but we don't have facilities to measure them in real time. So the future of BIM and the future of clean rooms is having sensors measuring the real issues, whether they're organics, whether they're microorganisms, and there are now new technologies to measure these devices. So the photograph on the right-hand side, if I can point to it, well, there shows an example of a real-time biofluorescent particle counter measuring microorganisms in a facility in Svetozar in Slovenia, where they're showing you the left-hand side is the number of particles, including microorganisms. So we're using these type of sensors to recognize where the contamination is, and that's fed directly back into the HVAC system. Okay, I will finish on that point. Thank you so much.
Thank you. Thank you very much for this inspirative presentation. Any question maybe this moment, or a little bit later we will have a chance to discuss later or the coffee break, or after that at the end of the Congress. Thank you very much once again. Thank you, Gona.
Thank you very much.
Thank you. Our next presentation is a simulation of the effect based on the number of passengers on the thermal comfort in air-conditioned vehicles by Mr. Svetozar Grahovac. The presentation is going to be in Serbian, I think. So if you need headphones with translation, please, you can use it.
Ja moram da pristanem da to dođe. Moment, je ovdje greška neka.
No. Druga. Grahovac.
Jesam. Poštovane dame i gospodo, posebno mi je zadovoljstvo da izložim rad simulacije uticaja broja putnika na termičku ugodnost u klimatizovanim vozilima. Ovdje je dat sadržaj rada, što znači uvod, teoretske osnove, mjerenje parametara termičke sredine u klima kanalu sa vjetrom, rezultati, zaključak i komentari, na kraju kratak osvrt na literaturu. Postizanje ugodne klime je veliki izazov za proizvođače vozila za transport putnika. To što je najvažnije, ugodne klime nema bez potrošnje energije, što je se problematično pojavilo u zadnje vrijeme, posebno kod električnih vozila, gdje se ta dobra klima znači da vozilo ima kraći domet. Mjesto i način eksploatacije vozila su ključni za ispravan rad sistema klimatizacije. To znači, ovisi od toga gdje to vozilo treba da bude korišteno, da li je to Švedska ili je to, na primjer, recimo Španija, što znači Španac treba dobro hlađenje, Šveđanin treba dobro grijanje. Kupci vozila često traže da mi tu klimu verifikujemo, da je praktično dokumentujemo i dokažemo što oni žele. Ovdje je interesantno, mi smo to promjenu putnika simulirali praktično uključivanjem i isključivanjem isparivača i grijaćih tijela. Korištena je načina komfora gdje sam ja određene parametre mjerio koji su kasnije korišteni za simulaciju. Naravno, kada mi ta 4 termička parametra termičke sredine izmjerimo, onda je važno da li osoba sjedi, da li osoba stoji i šta je osoba obukla. Ja sam ovdje praktično dao ovu sliku koju sam prikazivao na više kongresa, oni su tu nabrojani. Kćerka me je pitala da li ja uvijek jedno te isto pričam, međutim, ta slika je zgodna tu praktično da se vidi toplotni bilans osobe. Mi kažemo sad ako bi ta toplotni bilans ova gore načina bila jednaka nuli, to bilo idealno, to je za poželjeti, međutim mi bi tada imali praktično 5% nezadovoljni. Ja se ovdje osvrćem na ISO 7730 koji smo mi morali koristiti, to je od nas traženo, to je ta teorija profesora Fangera, praktično je, koliko se sjećam, bio ovdje na 29. kongresu, praktično preduzeća su stvarno tražila, RATP Pariz je tražio 2005. da mi tu teoriju primijenimo i da im dokažemo kakva je klima na određenim mjestima koja su izabrana u autobusu. Znači ta osoba odaje ništa posebno, odaje vlažnu toplotu, odaje suvu toplotu praktično i što je još rečeno da li sjedi, da li stoji, tako da je ta metabolična toplota ovisna od toga u kojem je položaju osoba. Ovdje su date ti parametri praktično termičke sredine, oni moraju da budu ovim granicama praktično da bi taj program radio. Program se nalazi iza 7730 koji sam ja donekle dopunio i praktično prilagođavao i da bi mi te praktično, kako se kaže, indeks srednjeg glasa gore da bi ga mogli odrediti i ta teorija važi za između vrijednosti -2 plus 2, što znači to su te preporuke za taj program. Ako ovih 6, na primjer, parametara ne bi bilo u tim granicama, onda ne bi se to moglo proračunati, ne bi važila ova teorija. Tu sam ja dao jedan isječak praktično iz mjerenja koja sam ja koristio. Mi vidimo ove crne vrijednosti, na primjer dolje je brzina, gore je temperatura zračenja, se ne stalno mijenjaju, iz toga je razloga bilo potrebno za ovih 6 intervala vršiti usrednjavanje tih parametara, praktično da se one usrednje da bi se mogli učitavati u računarski program. Međutim, rezultati, procenat nezadovoljni, oni su, ja ću to kasnije pokazati, nisu dobri, međutim mi smo imali ovdje jedan sistem koji je vrlo bio jeftin i on se naziva na engleskom lowline, praktično jedna jeftina verzija koja je imala ventilatora koji su imali samo 3 stepena, pa se vidi na broju 17 kako se te stepenasta regulacija, da se ta promjena ventilatora vrlo brzo mijenja, za razliku od, ovo je bio jedan jeftini gradski autobus. U modernom putničkom autobusu praktično onda regulacija ventilatora kontinualna, tako da bi rezultati bili bolji nego što su ovdje ispali. Tu su dati praktično rezultati. Na tabeli 1 sam ja ti 6 intervala predstavio, temperatura praktično termičke sredine, vlažnost vazduha, brzina nastrojavanja, temperatura crne kugle i praktično temperatura zračenja. Znači to su ti parametri koji su učitavan računarski program. Da bi se u tabeli 2 je bilo slučaj sjedenja, znači osoba sjedi opšteno, ima metabolizam 1, izolacija je bila 0,7 klo, što smo praktično ja u radu naveo, međutim u standardima se preporučuje ako osoba sjedi, da se onda uzme uticaj sjedišta za oko 18%, tako da je tu na desnoj strani PPD-1, to je procenat nezadovoljni, znači on je bio u početku relativno dobar i kasnije je bio lošiji. Interesantno je tu vidjeti tu toplotu osobe koja ona odaje Q0,1, znači to su te toplote koje su više od pretpostavljene, znači osobe je bilo hladno u ovome slučaju, znači sjedenje. Za slučaj izolacije 0,7 klo, onda dolazi tabela 3, gdje mi imamo sjedenje isto, praktično je statička izolacija ovdje će nešto povećana. Tu su vrijednosti nešto bolje, znači procenat nezadovoljni na desnoj strani, praktično procentima nešto bolji nego što smo imali za prethodni slučaj. I najbolji slučaj je 4 dolje gdje osoba stoji, praktično nema višu metaboličnu toplotu, znači u slučaju stojenja i ona je najzadovoljnija. Znači to su ti rezultati u tabelama koji sam ja kasnije prebacio ovdje na dijagrame, znači tu su odate toplote, dolje se vidi horizontalne su metabolične toplote, naravno za stojenje M3 praktično više nego za sjedenje, ali se vidi da su prema ovoj analizi da su toplote veće koje su odate, na primjer, nego što smo mi pretpostavljali, znači osobi je hladno. I ovdje je ova prethodna toplota pomnožena sa površinom osobe. Ja sam uzeo standarda za ovaj slučaj osobu da ima visinu 170 cm, 69 kg je teška, ima površinu tijela 1,8 kvadratnih metara i tu su date praktično ukupno odate toplote osobe za ovih 6 intervala. Tu je procenat nezadovoljni praktično dat. Vidi se da su zadnji 5 i 6 intervali nisu tako dobri, međutim, kako sam rekao, to se može objasniti jeftinijom i lošijom regulacijom koja je za to odgovorna. Uobičajeno u normama da se praktično vozilo ohladi i da se onda praktično izvrši isključivanje tog toplotnog opterećenja praktično i onda je to bio razlog da su ti procent nezadovoljni bili relativno visoki. A što se tiče, ovdje sam zaključio komentari, mogu reći, ova analiza je pokazala temperature sredine i brze promjene kretanja vazduha s razlozi naglog porasta procenta nezadovoljnih, poslije zadnji 5 i predzadnji 6 interval. Toplotno opterećenja određena primjena značaje komfora su iznad željenog opterećenja, bilo što nije bilo ni čuda, znači ona su bila viša nego što smo mi pretpostavili, što sam ja pretpostavljao. Jer uopće u tim normama kada mi radimo, to polazi se od pretpostavke da osoba odaje 120 vati. Uvijek je važno kod tih, praktično kod tih mjerenja i poređenja da se na isti način poredi. Jer sad, da li je sjedi u autobusu đak ili sjedi neko koji ima možda 100 kg ili neko kao ja, praktično moja bi toplota bila u slučaju komfora 120 vati sa mojom težinom, visinom. Na primjer, tu sam dao pod 3 za termičku ravnotežu tijela i metabolizam od 58,15 vati po kvadratnom metru. Znači, osoba je odavala 105 vati, ova osoba je standarda koju sam ja praktično preuzeo. U mome slučaju je bilo to 120 vati. Kupci su tražili, na primjer, zahtijevali od nas za sjedenje da se uzme toplota 94 vata, za stojanje 126 vati. To je bilo moje zadnje mjerenje u Beču, praktično gdje su tako kupci od nas to zahtijevali, da mi sa tim vrijednostima kalkulišemo. To je bio jedan zlobni autobus i smo mi imali oko 120 sjedišta, znači mi smo došli do unutrašnje toplote oko 14 kW. Ovo što ponavljam ponovo, kada kupci su tražili da se jednačina komfora odredi procenat nezadovoljni, to je bio RATP Pariz praktično. I interesantno, ja sam tu neke stvari sporedno naveo, temperatura vazduha u vozilu može biti znatno iznad temperature okoline. Mi smo 2001. imali masovne reklamacije u Španiji. Mi smo imali slučaj da gdje sam ja imao ručni jednostavni aparat za mjerenje i onda sam bio sam iznenađen da iako naš klima sistem radi, mi smo imali temperaturu vazduha u vozilu iznad okoline. I moram reći, ja sam brzo to sve sakrio da ne vidi kupac da je ta naša klimatizacija loša, međutim mi smo morali poslije oko 80 autobusa da prepravimo da bi ih dobili na nivo da je kupac zadovoljan sa tim. Što se tiče sunčevog zračenja, ono se ne treba ispustiti iz vida. Ja sam imao slučaj, sad sam više oslonio se na praksu, da smo vršili mjerenja u Beču u Arsenalu. Arsenal je ovdje na 29. kongresu predstavljen praktično u sali. Tadašnji direktor Arsenala je podnio izvještaj kako taj njihov klima kanal funkcioniše. Ja znam da su kolege, profesor Todorović ili iz Kraljeva, da su oni vršili mjerenja u Beču u tome kanalu sa vjetrom, jer on je namijenjen isključivo za praktično za željeznicu, a smo ga mi koristili za naše zlobne autobuse. I imali smo slučaj da smo za 45 minuta od 50 stepeni došli na 26, kada smo uključili sunce, onda nismo došli više nego na 30. Znači, oni mogu tamo se može sunce simulirati 18 vati po kvadratnom metru, 30 stepeni prema horizontali, znači to je bilo vrlo bitno, jer mislim, uticaj sunca u praksi je praktično i putnika je vrlo važan. Međutim, sad na kraju, mislim, rada, zašto sam naveo dalje moj magistarski rad, 92. je bila davno kad sam ja bio mlađi nego danas, znatno mlađi. Moj mentor je bio profesor Emin Kulić, on je već 20 godina među nama, nažalost. Tako se desilo i mi smo, ja sam bio praktično vrijeme član, ili mi smo bili motori vozila i više nam je bio poznat JUM, Jugoslovensko udruženje za motorna vozila, i onda se pojavila potreba praktično da se ta tema radi u fabrici specijalnih vozila u Famosu i profesor Kulić je bio vrlo pravičan i on je stvarno najurio iz kabineta i onda smo našli nekakav kompromis da je on meni rekao moraš na KGH da ideš i da se tu, da čitam časopise da bi nadoknadio onaj znanja koja su meni nedostajala, što bi ja rekao nakon toliko godina da je nekako ovaj kongres po mome bi rekao da bi nekakva, u mom slučaju, kovačica znanja. Znači da smo mi to mogli određene informacije da dobijemo i recimo smatrao sam to jako korisnim. I šta se desilo privatno, poslije 18. KGH kongresa sam upoznao moju suprugu, imao slučaja povratku iz Beograda za Sarajevo preko Prijedora, koja je studirala srpsko-hrvatski jezik i sad odstupam teme. I kada je trebalo da završim magistarski rad u Njemačkoj, profesor Kulić je bio opet pravičan i kaže kolega ne Njemačka nego Kanada. I kad sam svu municiju potrošio, ja nisam, jedno sam imao slabost, nisam naučio engleski jezik, ja njemu kažem profesore ne znam engleski. Kaže, o meni nisam znao ni ja, pa sam naučio, ja njemu kažem, profesor, ali u Kanadi nemam djevojku, u Njemačkoj imam jednu. I tako je on potpisao te preporuke, ja sam otišao u Njemačku, ali me vežu za ovaj kongres ili za sve to neke drage uspomene, što kažem, mislim, bilo je jako lijepo, osim toga stručnog karaktera koji je kongres nosio, mi smo tu njegovali ta druženja, kolega Golubović tu praktično sjedi, mi smo praktično pratioci, preko 30 godina pratioci kongresa. Ja sam malo stupio od teme, ja se izvinjavam, zahvaljujem se. Zahvaljujem se, ako ima nekih pitanja, tu je moja adresa, ja još jednom kažem, klimatizacija vozila, meni je ovdje bila čast da sam ja mogao da izlažem te teme, iako ta tema više pripada udruženju motora i motornih vozila. Hvala na pažnji i praktično ako ima nekih pitanja sam spreman da ih odgovorim i ja sam gotov.
Hvala.
Mislim, gotov sa izlaganjem.
Da li možda ima neko pitanje iz publike? Ako nema, zahvaljujemo vam se najlepše na prezentaciji. Svakako možemo.
Hvala.
I vidimo se na narednom kongresu.
Ja se nadam, je bilo jako moguće, sve moguće. Hvala.
Thank you very much, dear colleague Grahovac. The next presentation and next paper is from our dear friend Dimitris. He's coming from Greece, from Hellenic chapter, Russia Hellenic chapter. Welcome, Dimitris, once again. The title of his presentation will be Indoor Environmental Quality and the Need for the Holistic Approach. So, Dimitris, please, the floor is yours.
Thank you very much. Good afternoon, everybody. I'd like to thank the hosts of this Congress and the opportunity for me to speak. I'd like to go to another direction. I'll be the heretic in the room, and I might be stating something obvious some of the time, but sometimes the obvious is unthinkable. The topic is indoor environment quality, of course. And what does it include? Everybody knows that. The environment quality definitely includes the air quality, thermal comfort, safety, health conditions, exposure to pollutants, and sound and noise. By the way, if I may recommend, you should have a monitor here because sometimes this is a bit difficult for the speaker to read. I do have my iPad, which is okay. So, healthy environment, right? What do we really need for a healthy environment? We need a sustainable and healthy indoor and outdoor environment. One affects the other. We cannot have a healthy environment indoors and outdoors to have toxic environment or wildfires. The only healthy environment that it's in a closed system that I know is of the submarine, but this cannot be maintained for very long periods of time or prolonged. So we need to, we are talking about the indoor environment now and how we can achieve this. So first of all, we need to have a real discussion, not amongst ourselves, the engineers, but we need to bring into the equation the architects, doctors, and other from the medical profession, psychologists, and in the end, the users or the patients. I'm biased a little bit more on the health side of the equation now, and I'll tell you later on, you'll understand why. So we definitely need to improve the indoor air quality. A lot has been said and done. I think we are very well on that point, and we don't need anything more. And the environment quality. And what we really need is to try and improve the physical and mental health. I'm a mechanical engineer in Athens, Greece. So one part of me is a European engineer, but I'm with Astra for the last 30 plus years. So I see things from the other side of the pond as well. And Astra has created the Environmental Health Committee that Connor is as well a member of. And we try to see how to improve the physical conditions inside the environment. In the States, there is a push from insurance companies to improve the indoor environment quality because they are paying a lot of money on sick leaves due to the poor conditions in the buildings. And this is hurting the companies big time. And what we really need to do is to have indices, not only global, but local as well. We need to have a set of global that can apply to basically the rest of the world, but we need to fine-tune it with local indices on how we have a healthy indoor environment. One of the topics that we haven't touched is maintenance. I've been discussing with colleagues from Greece, from Britain, from the US, that maintenance is not up onto a par as it should be. And this needs to be tightly regulated. I've seen conditions, and colleagues have seen conditions that filters are bypassed or pried open so that airflow will pass through, filters that are not full of dust, but they're tar black, and they basically do not work. Or I've seen whatever you might think. So we need to regulate it and having on a standard that cannot be challenged. And of course, we need to have surveys. So how can we achieve that? We create the standards, as we said. We create the policy and regulations. It is up to us to educate policymakers. Policymakers usually, they are not the subject matter experts as we are, so we have to train them as well. So we need to tell them what we really do need. And then we have to safeguard on what we are doing and how we're implementing for a better environmental quality and to keep our privacy, data not to be misused by commercial entities. And then we need training, continuous training. One-off training won't work it. Once is not enough. It's not enough in many, many aspects. So like Connor was speaking before for clean rooms. We had a conference in Greece on clean room technologies, and we found out that this needs to be continued, and we'll probably have it on an annual basis, because we need to keep on pushing and educating and have it everybody on the front of his mind, not on the back somewhere hidden. And now I'm trying to be in my time. Maybe I'll take some more. Okay. I have many things to tell you, but I'm not sure in what length I should go. Maybe I'll keep some for next year. And how do we maintain a healthy environment? We need objective measurements. We need global measurements that they are objective. We need early detection. We need to have a correct assessment. I'll be talking about the correct assessment a bit later on. And then we need to have a prompt response. All these, in one way or another, were obvious that they were lacking due to the coronavirus pandemic. So what are the hazards in a healthy environment? We have chemical hazards, airborne chemical hazards, gaseous or particulate, and the SVOCs are both gaseous and particulate. There are some terms that some of you might be familiar, some not. And then we have biological hazards that they exist, and we have physical hazards that are excessive level of ionization, non-ionization, electromagnetic radiation, noise, vibration, illumination, sound, temperature, and force within the environment. We don't pay much attention to this. And of course, we have the ergonomic hazards, repetitive motions, excessive force, physical damage. If I may stop here a little bit and tell you something that was presented to me and to us in Greece by a doctor that said they're now trying in Britain to have windows in operating rooms. And this was a mind-blowing experience for me. I thought for clean air, I said no, just to have a feeling with the outside environment. A patient is most of the time under with anesthesia, but the medical staff in the operating room have this surgically clean room for a prolonged period, and that affects them psychologically, and we need to look into that. We also need to look that we want an environmental quality, but this is a balance, as many things are a balance in life, but it is a dynamic balance. We need to be able to adjust in a microenvironment or on a time period. So to have a healthy environment, we need really to remove all these carbon monoxide, carbon dioxide, probably that you are all knowledgeable of, the ozone, or particulate matter, whether it's, depending on where we have it, 2.5 or PM10. And then comes the nice stuff, the VOCs and the SVOCs. The VOCs are volatile organic compounds that are included in building materials. And in cleaning products, they are in everyday use products that we do not pay much attention as engineers, and we should. And then there's, of course, the semi-volatile organic compounds that, again, that they are in building materials and consumer products, like toys, lotions, nail polish, perfume, cosmetics, things that an engineer wouldn't think of. And then we have the pathogens, the viruses that they might appear. In my mind, the last COVID wasn't the last pandemic that we've seen. Humanity has been through several pandemics. So we should not forget what we've been through and try to work and be prepared for the next one. It needs a total change of thinking, designing, and implementing of what we are doing as engineers. One way to do that is to have sensors in the environments. So we can have either stationary or wearable, and this can correlate directly with health metrics. Now, what is the problem with sensors? I've been asking with others, and they said, we had this building full of sensors, and the lights would go on and the warnings. So what they did, they turned them off. A simple solution to a problem, which doesn't solve the problem really. And we need to evaluate what is the most important risk or threat that's coming from the sensor. And I think that it's way past the human capacity. So we need to have an AI system that will evaluate the threat, which is really a threat and has to be looked after, or which is a malfunction, or which is a minor disturbance that the sensor shouldn't be ignored, but shouldn't be tackled immediately. And that's how we can move forward. We have to use, I've been hearing many different silly things about artificial intelligence that will take over. In my mind, it's simply an improved condition of the automation that we have. And as with everything else in life, it's how we use it, not what it can do. And now, the sensors really need to be specific to pollutants, have a sensitivity to the exposure, be cost effective, and this is the most important. We have to be able to use them, we have to be able to upgrade them easily, we have to be able to install new sensors into our already made system and upgrade or replace someone's. If we find something new, we have to be able to do it easily. Sensors are dropping in price. Let me give you an example. The Hellenic chapter has a good working relationship with the Hellenic Navy, and next door an admiral is giving a lecture, and he told me, you know, what's the best way to have an asymmetric threat in a building? Put a radioactive core into one of the air ducts, and everybody will have cancer and probably die within a period of time. This is not detectable. It doesn't have any, it's not detectable, it doesn't have any smell, it hasn't got an odor. But a sensor for a radioactive material, it's 100 to 200 euros. So we could install them in critical places where buildings are needed to have safety, and that would probably save lives in the long term. And just for the fun, now we know that everybody's producing the smart watches and the rings that they will start measuring various aspects. And who are the best monitor persons? One obviously in an operating room or ICU, and the astronauts. That's the two most monitored persons that I know. And then we had the biomarkers, and this is an interesting point that a doctor from Ireland that came to a conference we had in Athens and gave us an insight and how we can, we had a conference, I'll be speaking a little bit more in a short while, and we had the pleasure of having doctors that came and gave us their point of view, and it was mind-blowing, really, and I would recommend that you might like to consider doing that for next year here even. And what are the advantages of biomarkers? I'll refrain from reading them. You read reading them out, or you read it already. So, I would like just to close my presentation with a recommended read. You can find useful information for what I'm saying, or if you want to do on the handbook of ASRAE, the fundamentals. It It's going to be updated next year, the 2025 handbook. And there are these 3 chapters that they are worthwhile. And of course, there's there as a standard 241 that it is control of infectious aerosols. Furthermore, there are 2 links that you might consider if you want to go to the Environmental Health Committee that updates the latest information that it has. And there's the coronavirus response resources from us and others. The link will be updated and included probably in the Environmental Health Committee in the future. Now, the path forward. As we said, we need standards, rules and regulations, and advanced design guides to know what we must do and to help us do that. Basically, we do need collaboration with everybody. Not only architects, but we need from the medical field, we need from chemical engineers, and we need from everybody, even users from a building. And we do need to start having a continuous monitoring of the health indexes and have a regulated maintenance and be sure about that. This information, we need to start using the cloud, so all the professionals that they are interested in a certain project, they can have access to information, not to be compartmentalized and stay there without being useful to other people. So we need to have the conversation on with research, conferences, seminars, and training, and technical visits if possible. I would like to take the moment just to, as we say in Greece, the priest has to bless his robe before he goes to the other people. We had this health and safety session, which was an eye-opening session to the tune that we are dedicated in having a conference in the future on this subject as is, not anything else. And then I would encourage you, if you want to see these and the other presentations, you can go to the astre.gr site, where we have on the site of the conference, we are uploading all the videos and the presentations. And just to give you an indication of who was present there are a few faces that they are missing, and we tried to be holistic in our approach who was speaking, and we had the pleasure of having Aleksandar with us at the conference, and hopefully next year we'll have more from Serbia. Thank you.
Thank you, Dimitris. Thank you very much for a great presentation. Do we have any questions, comments, remarks? Please, Connor.
Thank you, Dimitris. As you know, we're both on the EHC committee in ASHRAE. I'm interested, we talked about sensors. Do we have any idea whether some of those sensors are becoming commercially available at a price point that people can afford? Because we can talk about IEQ and IAQ, but unless we have things we can add into our homes, like a lot of us have portable CO2 monitors we bring with us, right? But where do you see the sensors going, and from a commercial viewpoint, if you have any guidance on that? Thank you.
Personally, I think that the price of sensors is coming back. It depends on whether you are talking about a flat, a home, or a building big in size, maybe a university or a hospital. That it's a different ball game there. They have the means, and they should implement all the sensors without any question. This will trickle down to our houses. Obviously, we do not need radiation sensors in our house. It's too much. But radon poisoning is not that uncommon in Britain that they have everything closed. What we are saying, we're trying to be energy efficient. Let's have a passive house. Let's have as less clean air from outside, and we are talking about effective clean air on the inside, recirculating the air and filtering it. And what happens if you have an outbreak inside? Our model doesn't work. It stops working. So we need to dynamically be able to shift to another condition. That's what I have been saying. We need a dynamic balance. And the sensors will warn us, and they should warn us correctly without having false alarms on the conditions that exist, where they exist, and what we can do. AI will help us make better decisions. A human will make the final decision as he should. We cannot automate that.
Thank you very much, Dimitris.
Thank you.
Is there any other questions, remarks? Okay, thank you very much, Dimitris. Hopefully we will see you next year with your colleagues also from the chapter.
Evo, pri kraju smo i ove sesije i ovog našeg kongresa. Ja bih zamolio Milicu Milisavljević da izloži svoj rad primjena čistih soba u industriji prerade soje. Izvolite.
Dobar dan svima, ja sam Milica Milisavljević, inženjer prodaje tehničkih rješenja u Eurocons grupi i zadovoljstvo mi je što ove godine mogu da vam predstavim naš projekat primjena čistih soba u industriji prerade soje koji smo radili u saradnji sa Soja proteinom. Eurocons Group osnovan je 2003. godine u Vršcu. Kompanija Eurocons je lider u regionu u oblasti industrijskog inženjeringa, dizajna kao i ponudi opreme vodećih multinacionalnih kompanija, pre svega za farmaceutsku industriju, ali i za ostale industrije kao što je procesna, prehrambena i sve više automobilska industrija. Nudimo vrhunska tehnološka rešenja čistih soba po principu ključ u ruke. Eurocons Group kao matična kuća okuplja oko sebe još 4 firme, firmu Biro Plus, to je naš projektni biro, Darniko, naša izvođačka kompanija i osnivanjem firme Darniko dobija se validan oslonac za sve montažne, servisne i građevinske radove. La Prova, prva akreditovana laboratorija na Balkanu za validaciju čistih soba i ispitivanje kvaliteta vazduha i Econs, naša firma u Hrvatskoj koju smo osnovali sa ciljem da proširimo tržište. Naša rešenja našla su primjenu u oblasti čistih i suvih soba, regulaciju vlage u vazduhu, procesnu opremu i opremu za pakovanje, rešenja iz filtracije vazduha, tretman voda, hidropneumatsku tehniku i naravno sve to praćeno našim ovlašćenim servisom. Kao što sam već rekla, zastupamo vodeće multinacionalne kompanije koje proizvode opremu za farmaceutsku industriju, ali i za sve ostale industrije, pri čemu naša rešenja poboljšavaju energetsku efikasnost, smanjuju troškove proizvodnje i veoma često su od presudnog značaja za kvalitet i trajnost proizvoda. Kompanija je snažnija utoliko što preko 20 imamo zastupništva i proizvođača opreme. Evo na ovom slajdu možete vidjeti sva naša zastupništva. Eurocons pruža consulting koja se bazira na state of art rešenjima, projektovanju, izgradnji, instalaciji opreme, puštanju objekta u rad i validaciji i naravno servisu i postprodajnoj podršci. Sad bi da kažem par reči o čistim sobama. Znači šta su to čiste sobe? Pod pojmom čiste sobe podrazumevamo prostor koji se sastoji od jedne ili više prostorije namenjene za proizvodnju ili pakovanje nekog proizvoda ili u svrhu naučnog istraživanja. U čistim sobama je stvaranje i zadržavanje čestica svedeno na najmanju moguću meru, a takođe i drugi relevantni faktori kao što su temperatura, vlažnost i pritisak se po potrebi mogu kontrolisati. U početku čiste sobe su se koristile za farmaceutsku industriju, a vremenom se sve više koriste i za druge industrije kao što je prehrambena, a primjenu nalaze i u automobilskoj industriji i proizvodnji mikročipova. U posljednjoj deceniji javljaju se specijalizovane verzije čistih soba, takozvane suve sobe, odnosno dry room, u kojima je pored određenog kvaliteta vazduha potrebna i ekstremno niska vlažnost vazduha. Soja protein, gde smo mi radili čiste sobe, znači soja protein je najveća fabrika za preradu soje u Srbiji. Po kvalitetu i kapacitetu prerade od oko 250.000 tona godište spada u najznačajnije prerađivače non-GMO soje u Evropi, a istovremeno je jedina, to jest jedna od malobrojnih fabrika koja prerađuje isključivo genetski nemodifikovano sojino zrno i samim tim koje je strogo kontrolisanog porekla i samim tim to daje vrednost celokupnom asortimanu koje kompanija plasira na domaće i inostrano tržište. Proizvodi soja proteina su za ljudsku ishranu i mikrobiološki rizični i može doći do kontaminacije proizvoda, odnosno nepoželjnog razvoja mikroorganizama, što može dalje uticati na zdravlje korisnika. Pakovanje mora biti u mikrobiološki zaštićenoj atmosferi, to jest sredina mora biti mikrobiološki ispravna i izgradnjom čistih soba taj cilj je postignut, odnosno postignuti su vrhunski higijenski standardi. Naravno, tu je bilo i problema kada se krenulo u izgradnju čiste sobe u soja proteinu. Prva linija za eksploataciju je već bila montirana i čistu sobu smo morali da montiramo oko postojeće linije. U okruženju čiste sobe nalazi se teksturirani sojin proteinski koncentrat koji je sve popularniji u veganskoj ishrani i sadrži 65% proteina, a na drugoj liniji nalazi se teksturirani sojin protein koji sadrži 50% proteina i naš finalni proizvod ispunjava sve higijenske uslove. Što se tiče filtracije koju smo radili u soja proteinu, radili smo kamfilove filtere. Kamfilovi filteri se koriste širom sveta za filtraciju vazduha da bi zaštitili ljude i okolinu od kontaminirajuće osetljivih tehnoloških procesa na energetski efikasan način. Kada se radi sa hranom, odnosno kada se hrana melje, ona je više izložena kontaminaciji i morali smo da ugrađujemo HEPA filtraciju na svim linijama. Sojino zrno kada se samelje je 1.000.000 puta veće u odnosu na to kada je celo zrno, a kamfilovi filteri se koriste i u farmaciji i u prehrambenoj industriji, industriji pića, a i u nekim teškim industrijama kao što je naftna, hemijska i brodograđevinska. Naša firma je u soja proteinu projektovala i ugradila filtere na svim linijama, na pneumatskom transportu, na liniji mlevenja i u čistim sobama. Tadašnja postojeća filtracija ogledala se u primjeni filterskog platna koja je klase čistoće G3 i G4, a novo primenjeni filteri su klase čistoće, to je grubi perivi filteri koji su klase čistoće G2, grubi filteri klase čistoće G4, fini vrećasti filteri klase čistoće F9 i HEPA apsolutni filteri klase čistoće H13. I da bi čista soba bila puštena u rad, neophodna je akreditacija svih kritičnih parametra. Iz tog razloga 2009. godine mi smo osnovali prvu akreditovanu laboratoriju koja se bavi validacijom, balansiranjem sistema, kalibracijom i tako dalje. La provu i validacija je esencijalni deo dobre proizvođačke prakse, a la prova nam može pružiti profesionalnu uslugu validacije čistih soba. Što se tiče validacije u čistih soba, u soja proteinu, la prova je radila komisioniranje HVAC sistema i IQ i OQ kvalifikaciju čistih soba. Komisioniranje HVAC sistema podrazumeva balansiranje vodene i vazdušne strane, ispitivanje curenja vazduha iz kanala, a IQ i OQ komisioniranje čistih soba podrazumeva izvođenje instalacione i operacione kvalifikacije za čiste sobe i za HVAC i klasa vazduha koja je dobijena u čistim sobama je ISO-8 u soji. I u današnje vreme primjena čistih soba u prehrambenoj industriji je postala standard i više se ne postavlja pitanje investicije u čiste sobe. Pomenula bih još neke prerađivače u sličnim industrijama gde smo uspeli uspešno da realizujemo projekte čistih soba i generalno otprašivanja. Objekat Bimal u gradu Brčku u Bosni namenjen je preradi uljarica i prilikom skladištenja suncokretove sačme dolazi do stvaranja velike količine prašine koja je štetna po ljudsko zdravlje i bilo je potrebno poboljšati kvalitet vazduha u skladištu jer su velike količine prašine bile u tom skladištu koje su se dalje bagerom sipale u usisnu korpu i cevima dalje išle u šleper. I efikasnim sistemom usisnih rešetki i otprašivanja, pre svega koša, kao i celog prostora, rešili smo problem prašine. Koncentracija štetnih čestica smanjena preko 10 puta, a merenjem u više različitih tačaka dokazan je zadovoljavajući kvalitet vazduha u celom prostoru skladišta. Takođe i čiste sobe mogu se primeniti za uzgajanje različitih vrsta biljaka u zatvorenom prostoru. Jedan od naših projekata koje smo takođe radili je Mar Medica, proizvodnja medicinskog kanabisa u Makedoniji, u Kumanovu. I znači čiste sobe mogu da se primenjuju od hibridnog otprašivanja biljaka do okruženja za inkubaciju, gde je kontrolisana temperatura i vlažnost. Naš kvalitet i posvećenost poslu potvrđen je sertifikatima i trudimo se, evo ovde možete videti na ovim slajdovima naše zadovoljne klijente i trudimo se da donosimo inovativna rešenja na naše tržište, da naši klijenti po završetku projekta budu zadovoljni i u toku sa tržišnim zahtevima. To bi bilo to od mene. Hvala na pažnji.
Hvala i vama. Hvala lepo. Evo, ovim bismo i završili današnju sesiju. Još jednom vas pozdravljam u ime mojih mlađih kolega, profesora, na kojima ostaje ne samo njima, ali svih njihovih kolega generacijskih, na kojima ostaje budućnost i naše struke i našeg kongresa, konačno i naših Srpskog društva za klimatizaciju, grejanje i hlađenje KGH, koji je i glavni organizator celog ovog skupa. Eto, još jednom zahvaljujem, želim vam sve najbolje u novoj 2025. godini, želim vam puno sreće, radosti, porodične sreće i uspešnosti na poslu i konačno dobrog zdravlja. Živjeli svima!